of this session. And there we go. All right, so welcome everyone to another edition of the March to the Edge series hosted by Kepware PTC. Really, this series is aimed at having conversations about the edge and edge connectivity and just industrial connectivity in general with our technology partners and other industry experts. And the goal here is to really have a conversation about it, and this isn't necessarily meant to be a sales pitch. So we will do our best to keep this conversational. Today, we are joined by our technology partner, HighByte, and awesome system integrator, Ectobox, to discuss connecting your business systems to the edge. So in this webinar, we'll be discussing the challenges of edge connectivity, as well as the need and importance of data modeling. And additionally, which I'm selfishly very excited about, Ectobox will actually be presenting a real life use case using both Kepware and HighByte. So that's coming up toward the end, and that should be pretty exciting. And again, just another quick note, the session will be recorded and you will receive a link to the recording a few days after the conclusion of this meeting. So, all right, why don't we jump into really quickly the fun stuff, which is our panelists. So first up from HighByte, we have co-founder and chief business officer, John Harrington. Hi, John. And John has spent his 25-year career both delivering software to manufacturers and working for manufacturers in various operations role, and brings a really unique perspective on how suppliers and the end user play an integral role in implementing the new technology solution. So welcome, John, and thank you.
Thanks, Kyle.
And oh, sorry, go ahead.
No, I just say glad to be here.
Oh, good. Excuse me. And then now, next up from Ectobox, we have Kevin Jones and Tim Burris. So welcome, Kevin and Tim. So Kevin is the CEO and lead strategist from Ectobox, a company he founded 20 years ago. He is an IoT Incorporated certified IoT professional and an active member and on the board of the Allegheny. Am I saying that right, Kevin?
Allegheny,
Allegheny Appalachian chapter of SMRP and a member of PMPA and NTMA. So welcome, Kevin.
Thank you. We've been looking forward to this conversation. It's going to be a lot of fun.
I think so as well. And of course, we have Mr. Tim Burris. So Tim is a senior architect and software consultant over at Ectobox. And Tim has worked in the software and technology space for 20 plus years for nonprofit, for defense, for-profit companies, manufacturing industries. And he leads Ectobox's new technology strategies, as well as driving design and architectural decisions for Ectobox's clients. So welcome, Tim. And I think, Tim, you'll be doing a lot of the use case at the end here.
Indeed. Yeah. Thank you guys for having me. I'm excited.
Yeah,
absolutely. For sure. And finally, I will be your host, Kyle Carreau. Don't have as an impressive resume as these fine folks here, but work for Kepware, partner enablement engineer. I've been in the industry for 8-ish years now, heavy background with Rockwell, and now Kepware for a long time. So, all right, so before we hop into discussion, I know at the beginning I said, it's not really gonna be a sales pitch, but I mean, let's be real, at the end of the day, we're all salespeople. So bear with us for a few minutes. We're just gonna take a few moments to kind of go through and have everyone kind of just talk about their companies if you're not familiar with them. So John, let's actually start with you and HighByte.
Okay. Thanks, Kyle. So HighByte is a software company. It's focused on selling solutions into the manufacturing industry, and specifically we're focused on data infrastructure solutions, really to address a lot of needs that have come up as companies have tried to adopt an industrial transformation strategy or an industry 4.0 strategy. HighByte was founded about 3 years ago now, and it was founded by Tony Payne, Tori Penrod-Canberra, and myself. We had all worked for many years together at Kepware, so we're excited to do this webinar now that we're partners with Kepware and working with the old team that we used to work with day in and day out. So I'm going to talk a little bit more about the solution later on in the webinar. So I will stop there and turn it back to Kyle to introduce the Ectobox team.
Great, thanks, Sean. Yeah, and it's really awesome working with all the folks from HighByte, as they all came from Kepware, and actually we're right down the street from one another. So it's makes for really cool little interaction, especially in all the places. Portland, Maine. Like who would have thought of that? All right, so now I'll actually hand it over to Ectobox. So Kevin, why don't you tell us a little bit about the company you founded 20 years ago and where we are today?
Sure. Thank you, Kyle. I appreciate that. Very briefly, Ectobox is an industrial intelligence solutions company. A lot of different ways you could describe it, but industrial intelligence solutions company is one of them. Our focus is to help manufacturers operate more efficiently and grow. And very often what we end up doing is working on challenges that companies have within the four walls of the manufacturing plant. And typically we're coming in, talking with companies about challenges they have around machine downtime, production efficiencies, or conversation we had this morning with a company, where is our WIP? Where is our inventory throughout the whole process, or its quality, or its manual data processes, or old technologies and replace it, all those kinds of things. And so within those four walls of the manufacturing plant floor, we'll end up talking about machines, automation, machine connectivity, Kepware and HighByte definitely come into this whole span, as well as the software, the data analysis, and getting those projects in place. And we'll talk later about some of the other ideas, but that's really what we're about, is solving those business challenges within the four walls of the plant, going from all the way from machine up to software and data.
Awesome, thank you, Kevin. Yeah, and Ectobox is really, as you just heard, it's pretty unique because they're not just an OT integrator, they're not just an IT integrator. They really are one of those system integrators that understands the entire process, from the supply chain all the way down to the bits and bytes of the I/O within the PLC. So it's really unique, and yeah, you'll be hearing about all their expertise at the end here, and it's really exciting stuff. And lastly, I'll spend a little bit of time talking about Kepware, more specifically our Kepware Edge product, but more or less Kepware has been around for 25 years or so now, dealing solely in industrial connectivity. So you may know us as the driver company or the OPC people, and I mean that's what we do. We solely focus on unlocking the data that is in your factory from all of these different data sources out there. So all those different PLCs, those databases, other sources like that. Kepware is the solution for you. We go in, we have all these drivers, we can connect up to these devices, pull data out, and then send the data where it needs to go. More recently, within the last 2 years or so, we actually released a new product called ThingWorx Kepware Edge, which is really focused more around edge connectivity. So as opposed to being based on a Windows OS, it's now based on a Linux OS. And then there are specific edge type features and packaging that goes along with it that really is aimed at these larger distributed IoT type of applications versus the traditional Kepware or KEPServerEX product, which is found within the four walls of the factory. And something really excited that actually just came out yesterday is Kepware Edge is now available on the Azure Marketplace. I don't have a lot more information than that. There's a more formal announcement coming in a little bit here, but it did just get released last night. So if you are looking to deploy and download Kepware Edge, you can do so now on the Azure Marketplace. So we are really, really excited about that. Okay, so commercial's over. Let's get into the fun stuff here. So first up, I'm going to be talking, we're going to be talking a little bit around the challenges of edge connectivity. And really, we view this in sort of three different buckets. The first is defining the edge and where the edge is. And, for someone that works in OT, I think the concept of the edge is familiar, though calling it the edge might be a little bit different. Whereas conversely, like an IT or an IoT person may be familiar with the term, but they also recognize the how ambiguous it can be. And actually, Kevin, I'm going to ask you, just for being around sort of the OT and the IT space for so long, do you find this to be true? In other words, are you seeing people use edge more, or is it still like, where do you see that, I guess?
I see two things, at least. One is confusion on what is the edge and people using that term maybe a little bit too loosely. And the second is that I definitely see a increased use of the edge. And from our perspective, I'll refer to in some of our later conversations, 4 tenets that we use to make decisions, technical decisions and strategic decisions on projects. And one of them is push everything as close to the edge as possible, or I should say as reasonably possible, because then that just saves a lot of headaches, a lot of challenges and whatnot. It can present some new challenges, but we definitely see a lot of that adoption, and we're helping drive some too, because it does make a lot of sense.
Awesome, excellent. Yeah, and that's actually feeds into my next slide perfectly, but we'll pause that for a second. But the other challenge here too is just the variability of protocols as you get closer to the edge, or however you define it, which is pretty specific in the next slide, as you'll see. But just the wide range of protocols that you can get to the edge. I mean, it might be BACnet, it might be Modbus, it might be Allen Bradley specific, it might be an oil and gas, EFM specific type of protocol. It might be Mqtt. There's a whole lot of different protocols out there, and the challenge is, like, yes, we have all this great technology that can interpret and do these crazy analytics with all this data, but the challenge is, like, you actually have to get access to that data, and that's really the big challenge, because there is just so much variability down at the edge or down at the plant floor. And then, of course, the last challenge is just the demand for data is just so high that it brings its own challenges. So, from a hardware standpoint, more data means that you need to figure out how to store it properly, how to process it faster. And from a hardware standpoint, again, you have to figure out how to scale that out efficiently across an enterprise, as well as, again, dealing with all of the different types of data coming through, and not even necessarily from a protocol perspective. I mean, the actual information coming through. Is it torque values? Is it OEE type of data? Is it quality type of data? Is it supply chain data? There's a whole lot of different types of data that you have to deal with and process. So, full disclosure, took the slide from Gartner, but I thought it was really excellent in really pointing out, like, the differences and the different types of definitions about the edge, really. So at the bottom there, you've got the physical endpoint, and that's quite literally just the I/O in the PLC. All the way up to the top there, the core, which is just that centralized cloud or the global data center, or really just the cloud in general. And that might be a public cloud, that might be a private cloud, but that's the top of it. And then everything in between there is sort of how they define this edge computing. And as Kevin was saying, you want to start some of that data collection closer down toward that physical endpoint, or closer down to the edge, as reasonably as you can. And there's a lot of reasons for that. But I just thought this was a really awesome reference to use when having that conversation of, well, what do you mean by the edge? Is it the device edge, or maybe is it the compute edge, or maybe is it all the way down to a smartphone? But really the key here when looking at the edge is, as you get closer to that physical endpoint, the mix of protocols increases, but the data volume decreases. And then inversely, as you go up closer to the cloud, again, in general, the data volume is going to increase, but the mix of protocol is going to decrease. So just sort of things to keep in mind there as you're trying to architect some of these solutions. And then finally here, and again, this is really where Kepware sort of fits in and hopefully solves some of these challenges, is it helps solve that getting access to those diverse set of industrial protocols down on the factory floor. So it does a really great job of connecting up to all those devices, and then being able to translate that data into different types. So whether it's into OPC UA, trying to send things to, let's say, a SCADA system, whether it be Factory Talk or Wonderware or Ignition, it can convert things directly into something ThingWorx calls its always on protocol, which is our native interface to ThingWorx. Or, hey, maybe Kepware needs to convert some of these protocols into cloud ready protocols like Mqtt or REST. Now, with that, that solves a big challenge, but that's really only half of the battle. As this team alluded to earlier, IoT and sort of this new industry 4.0, choose your favorite buzzword, it's more than just unlocking that factory. There's a variety of other data sources that can be tapped into to make better business decisions. And a lot of that has to do with just, again, the variety of different sources. but you need a way to solve that. And actually solving that can be solved by data modeling. So with that, I'm actually going to turn it over to our in-house expert, John Harrington, who's going to be talking about the importance of data modeling once you do get access to all of that data. So John?
Yeah, thanks, Kyle. Appreciate that. And Edge is definitely an interesting topic. I remember I had a conversation with a company a few years ago, and a factory, and I said, well, factories don't really have an edge. And they said, no, we do. It's actually the product going down the line. And the product is their edge, and then it kind of goes out from there until you hit the data center. So it's pretty interesting to think about how do people define the edge, and that chart that you showed is pretty pertinent. So I'm going to talk about another challenge that companies are facing with Industry 4.0 and with digital transformation and with kind of this new evolution, and specifically around data and data modeling. So if you look at Industry 3.0, where we're all coming from, and a lot of companies are still here, Industry 3.0 was really focused on automation and control. And how can we automate and control our factories much more efficiently and fast, quickly, and just get product out the door as quickly as possible. And from a system standpoint, companies followed this Purdue model, the stack of systems that you can see on the left-hand side of the slide. So starting at the wired I/O, moving up to the PLC and machine controller, moving up to your connectivity solution, that's where Kepware sits. Could be Kepware Edge, could be KEPServerEX, and then moving up into either a SCADA or a historian. And once in a while, we would connect it up to the ERP system, but largely the data stayed on the OT side. And people would use their SCADA systems or their MES systems to model their information, or even in some cases in HMI on the machinery. So the image that you can see on the right side is a typical SCADA image where you're getting these raw data points from the PLCs through Kepware, and you're attaching them to an image that you've drawn out of your factory. And that way you can add context. So it's not just a number. Now we can see where it is in the factory, where it's coming from. We can see maybe it's unit of measure. It may change colors if it shifts too much, or if it goes too high, exceeds a tolerance or a low tolerance. And so we contextualize information in the Industry 3.0 world in our SCADA systems. And that was really because that was the end of where that data needed to go. And that became a very convenient way of contextualizing information and modeling information. Each screen is essentially a model of information. Next slide. So if we move into Industry 4.0, Industry 4.0 is really based on getting the business access to the information out of the factory. So building on that automation and control and providing business access to the data. And the challenge with this is that over time, we've got all these different business functions that look for access to the data. So we've got quality engineers, we've got, sorry, I just drew a blank there on, Kevin had mentioned inventory, where's my inventory? So we've got people that are focused on inventory, we've got people focused on R&D. I was just speaking with a company today that wants to get their data to their R&D engineers. We've got the finance and accounting team, and we've got other people in our supply chain. And we're trying to figure out how do we get these people access to the data? And of course, they all have their own systems. So now we're connecting up a CMMS or quality management or the ERP system. And we've got these new IoT platforms and data lakes and cloud-based systems to be able to consolidate and make use of this data. And over time, we've tried to integrate those with the factory floor. And sometimes the data is there and we just pull it direct from Kepware. And sometimes the data is not available. So we throw down some edge gateways or some smart sensors and we connect those up as well. And what we've ended up with is this web of connections. Each one was built with great intentions. Each one was built efficiently. But the challenge is that as the factory then changes, it gets hamstrung by the integrations that were created. And this becomes very hard to manage and maintain as a company. So as we move to the next slide, Kyle, what we see is, and what we're hearing is this new architecture approach. And the approach is to put in take a hub and spoke approach to data architecture instead of that point to point that was really a legacy from Industry 3.0. So now with the hub and spoke, we're able to route the data through a data hub or a data ops hub that allows you to consolidate the data, standardize it, and contextualize it, normalize it, however you need to do, and then deliver it to those systems that need it. And in many cases, we're actually combining data from multiple systems. So maybe some real-time data combined with the MES, and then we'll move it up to the cloud for our R&D team to do some analysis on. So the key here is that we define a unified namespace. We leverage data models, both industry data models as well as models that we create within our company, but we leverage them so that the data coming off the factory is consistent and it's maintainable. If you move to the next slide, Kyle. And really, this is where HighByte comes in. So HighByte's solution is the HighByte Intelligence Hub. The Intelligence Hub we designed specifically for this problem that we heard from you all, from engineers, from people in industry, and it's designed to accelerate these projects by having a single hub that allows you to integrate your data on premise. It was built for the OT team because a lot of the complexity comes out of that factory floor data. It's that initial modeling and structuring of data coming off of the PLCs and machine controllers, but now you want to structure it for quality, or now you want to structure it for accounting or for a vendor, and you want to deliver it to them. So the focus with HighByte is really to provide an easy to use, a fast to use, an open system that's flexible and scalable and maintainable so that you can set this up and you can deliver it to your customer and they're able to then maintain it over time, or the integrator is able to maintain it over time, and they can see what data transformations are happening, and you can be as agile as the people analyzing the data need to be. So that's a brief overview of industrial data ops, of kind of how things have evolved into this new need. And now I think we're going to turn it over to Kevin and Tim to talk about how they've utilized both Kepware and HighByte in a use case that they recently deployed.
Thank you, John. So in listening to both you and Kyle talk, I keep thinking about so many parallels, of course, between the products that you guys are talking about, how they're used and how we've actually used them. I mean, you'll see some of these points come out, but just to kind of hit them first. Kepware, being able to look at what we ended up doing was connecting to a whole bunch of PLCs within one family or one manufacturer's set of PLCs that they provide, an OEM, a PLC company. But there are so many different varieties and let's call them models, and also various ages and additions. And we needed to connect to all those, and there's a whole lot of data as well. And Kepware was a huge leap from the previous solution to connect to those products. And then from the HighByte perspective, we are huge believers in that spoke data, or
the hub and spoke.
The hub and spoke, thank you. The hub and spoke model. We often throw up a Purdue or IC95 diagram and then a circle next to it with all the lines going into it. That becomes essentially the center of a data-driven organization. That becomes the single version of the truth. If you're going down the path of becoming a data-driven organization by definition. And then we implement the unified namespace so that naming is really easy and straightforward. And then, again, the idea that John's talking about, sharing that data becomes so much easier. And then the HighByte tool and what they've done to enable us to connect that data, to publish that data out and subscribe to other systems as well is huge, a huge benefit. So Kyle, if you could, to the next slide, please. And I'm going to talk about this specific situation. So this is a manufacturing company that produces a product that is kind of like an aggregate product. And that aggregate product is put on conveyors, put into bins. The product is tracked within those bins by layer, and then put on trucks and shipped out. They had an existing solution that they created 15, 20 years ago or so. One of the guys internal, real smart guy, created what was at the time a phenomenal solution. I mean, in fact, I remember looking at it 10 or 15 years ago and thought, wow, this is really cool. And then we continued to work with the company over the years, and technologies and trends and best practices have changed over time, and we've adopted those practices. And this product kind of stayed stuck where it was. And so with that in mind, it ended up being a product that was difficult to work with. There were a lot of custom applications, about 30 custom applications, in fact, to help run this solution. And it required a full-time person to maintain the system as well, which obviously is not a good idea, just this one system. Multiple PLCs at various ages of models that would pull data off the conveyor equipment, the QA equipment, et cetera. Machine connectivity itself to connect to those PLCs was old, was rickety, if you will, very brittle, and would fail frequently, would need a lot of attention. And given all of that, then you could only guess that it was really hard to add new features, modify the system, and do it reliably, and also to share out new data. If somebody had a new idea, oh, I'd like this data. Okay, let me get to work. It's going to be a little while, kind of thing. What they needed was to replace this existing solution from old technology to new technology, apply best practices to it. But because this was in a brownfield environment, the system really couldn't change for what data it reported out. They wanted something very similar to what they had already, because there are a whole lot of people in the field using the solution and relying on the solution. People operating a lot of really heavy equipment, a lot of data sources and data destinations, and it was just too big of a task to change the thing. So the idea was, let's replace it with something new, but also when we're putting this in place, make sure that we are making the right decisions using Industry 4.0 concepts, a data architecture, hub and spoke, or what we call a data hub or data broker, and using 4 tenets that we use to make decisions around products, and make sure that we create a product, or excuse me, a solution that is scalable and flexible. And we were able to end up doing that. So we created a solution where we replaced the front end of it, the parts that the users interact with. And then we used Kepware to replace the existing machine connectivity solution, of course. And immediately, the machine connectivity was so much more reliable. It was not a problem, and I'll ask Tim to speak to a couple of these points. It was not difficult at all to then create good, reliable connectivity to the variety of PLCs that varied, again, by model and by age. And it was able to handle the data. Tim, if you don't mind, a little off the cuff, just on the Kepware piece, how did that work out? How did that end up working, setting up the tool to connect to all those different PLCs?
I mean, frankly, it was pretty amazing that that I was a bit reluctant that connecting Kepware, we were really going to connect to some of these, that we were going to connect to devices that were 15, 20 years old and devices that were purchased, 2 weeks ago and were modern. I was definitely reluctant that we were going to get them all connected. We were going to get all these tags, thousands of tags brought in, that it would be that easy. And that's not a sales pitch. I just didn't think it was going to happen that easy. And sure enough, I mean, we got all of them, all the PLCs connected. We got all that data flowing in. It's been fantastic. And all the issues that they were having with the previous solution, the instability just gone, just literally vanished. So,
yeah. And that was, I think, a lot of the guys' effort was, again, supporting that existing solution, I think, wasn't it?
Yeah, for sure.
Yeah. So, Kyle, if you could go to the next slide, we'll talk about the new solution a little bit more. So on the other side, too, was HighByte. And you can kind of see it here. It wasn't intentional. It was actually by accident. But you can kind of get a sense of the hub and spoke idea here, where Kepware is pulling the data up from the edge into HighByte. HighByte then is doing a lot of the processing of the data, the modeling, and then doing connectivity to other systems. And then we have ended up creating kind of a hub and spoke where HighByte is a big part of the center of that. We also have data going out to a data broker, Mqtt data broker, to help with the connection to the ERP system. And HighByte connects to a lot of the other data sources as well. And we found HighByte to work really well for effectively replacing those dozens and dozens, or the 30 or so custom applications. All that custom code, I mean, again, I'll ask Tim to speak to this, but all that custom code was to model the data and then to provide that data out to the other places that data had to go. And it ended up saving a ton of time. And again, with the HighByte piece in place, you did not need a full-time developer to support the application on the back end, because again, rickety, brittle solution with all those applications and so many moving parts. Again, a revolution in its day, but now old technology and there are better ways, and HighByte really came in and helped a lot. And we're still using HighByte to model new types of data, new types of KPIs, because the company has found new uses for the data. I mean, what we've found over time in a number of projects is that there's usually a near-term ROI, which a lot of the executives really push for. But then what they don't realize, and what we are finding out, and it's true here, is that there's also what I'll call a latent ROI. There might be a better term for it, but I think latent is pretty good, which is once you have this data, as I've said for many years, there's that light bulb effect. That light bulb goes off over top of your head to realize, oh, wow, if you can do this, can you do that? And do you have this data? And I want that data. And that's already happening. And so we're already doing that with the tool. And so with that, we've been able to set up a really nice architecture for the solution. So Tim, a couple of the things that when you and I have talked about the solution before, it was the trucks and ERPs in the ERP system, and there were the layers in the bins. Could you speak to how HighByte worked for the trucks with the ERP system?
Yeah, so actually, if you don't mind, I'll start with the model of the layers, because I think that's important to get to why we need those layers for the end. So like Kevin said, we're replacing the system. We have all these legacy data sources, and we're not allowed to change any of those. Everything around this needs to continue to function as it did before we came in. So with Kepware and HighByte, we're able to come in and model this data. So what kind of models? All right, so on the screen here, it's kind of a simplistic view of what's really going on, but you have these conveyor belts, and they're taking product to these bins. But these conveyor belts are really a series of complicated conveyor belts with these different gates that open and close, and they control where the product goes. And then you can see there's a call out for this analyzer. So before the product gets dumped into a bin, this very sophisticated analyzer like inspects it using this crazy chemistry stuff to see the product and measure these different qualities of the product. And one of those qualities is moisture, because that's something very important. How much moisture content is in this product? So you have this product moving down the conveyor, it's going through these gates, and it's going to these different bins. So all of that's coming from Kepware. Kepware is telling us, oh, this belt's running, this gate is open. These scales say that this tonnage of product is moving across. And so we can figure out, HighByte can take all of those pieces and figure out which bin it's going to. But then you take it even a step further. So that analyzer is a proprietary system. They only allow you to have access to the data through a web screen. So we did write a little bit of code to go and screen scrape, which is like where you have code that goes to the HTML page, it extracts those measurements, and then it exposes them through a REST API so that HighByte can see them. And so HighByte's able to pick up that analysis on the fly, and it builds a model that's this much product, 5,000 or 1,000 tons of product is going into bin alpha. And here's the analysis. This is the moisture content is 0.45%. And there's a dozen other measurements, but we'll just stick with moisture. And so it dumps it into the bin. And so we have this model that says this is what's going into the bin. That gets pushed out to the Mqtt data broker. Any system, any person can look and see what's going on. These are the belts that are running based on what Kepware says, and this is the product that's going into the bin. So that's one kind of complex model. But when we start talking about layers, so we're historizing that data. So we record everything that's going into the bin, and then we have SQL Server, provide some aggregation. All right, so if this much product has been dumped in, if we break it into 5,000 ton layers, we know at the bottom of the bin, we take the tonnage, we average out the analysis, and we know that the average moisture content for the bottom layer of product is 0.3% or whatever. And you do that through all the bins. And so now you have these conceptual layers of what the product looks like in the bins. Well, so why is that important? This is, Kevin, specifically what you asked me about, which is it's important because when the truck pulls into the yard, there's the guy or gal there, they scan the truck's transport manifest. Kepware sees that scan come through, bing, oh, we got a truck here. So it sends the manifest number. HighByte receives that manifest number. It goes to the ERP system and says, hey, this manifest is here. Looks it up like, oh, this is customer Stanley Incorporated. We know that from the ERP. We also know that they're expecting to get 7,000 tons of product today. And importantly, we know that Stanley Incorporated, the customer for this manifest, we know that they require a product that has a moisture content of less than 0.45%. So now the guy or gal who's in the yard ready to load this truck knows who the customer that's there to pick up. They know what content, what quality of product they need. And then also on the screen are all the bins and their layers. So they look at bin alpha, they see all the layers, the bottom layer in bin alpha, and bin alpha has a moisture content of 0.5%. Well, that's over what this customer wants. So looks at bin bravo, that one has a moisture content of 0.1%. Okay, well that is pristine product. That's great. I can load from that. But it also looks at bin Charlie and sees, a content of 0.3%. That's a better bin to load from because it still meets the customer's requirements, but we're not getting rid of the most pristine product. And this is all important because it's happening instantly. As soon as Kepware receives that scan and the manifest, looks it up, the person in the yard knows exactly where they should load product from because all these systems are connected. HighByte modeled it all together and pushed it out for everyone to know. So, I mean, it's pretty amazing to do that instantly on one little flash of a reader.
And then just to start to wrap this up so we can leave time for everything else, one of the things that I remember you talking about, and that, I mean, I tell a lot of people about the energy you had about HighByte when we got into it, like you got really super excited about it. And I think one of the ideas, or one of the things that make you super excited about it was that you had to write less code, essentially.
I mean, like you said, we replaced 30 custom applications. This is, and I say code written to do very specific things. Oh, go get data from this source, put it in Access. Oh, go get data from here, put it in Access. Oh, another one that takes all those different data sources and aggregates it and puts it into Access. One that builds pages for the web. All these different applications doing, like you said before, building all these models, this custom code to build models. And instead, we wrote very little code. We wrote code to do screen scrapes. We wrote a very small amount of code to read XML files, but everything was to expose it to HighByte. And then HighByte was able to model it and send it out for everyone to consume instantly. So I love to write code for sure. But man, when I can put a solution in place that, I mean, literally replaces tens of thousands of lines of code with a user interface that anyone can go in and manage. I mean, it doesn't have to be a software developer now that can go in and model this data and make it available. You don't have to call on your dev team to say, all right, we want to pull in this new PLC data. Kepware can make it available. HighByte will pick it up and someone can model it. And it doesn't have to be me. It doesn't have to be a software engineer.
A sign in my mind for everybody on this call, a sign in my mind of a good software developer or a technical person is a guy or gal who wants to write less code, not more. That's a good thing.
Yeah, we focus on writing the important code, like the
important code.
Yeah, if someone else has already written the code to do it, which HighByte has done and Kepware has done, use them for that, and then you write the code that fills any gaps or this really proprietary.
There you
again,
go.
since we couldn't change these other systems, they weren't all doing open architecture like we would like. If it was all open architecture, we could have connected Kepware and HighByte to everything, but they're not. So we did have to write a little code to make those legacy systems available to today's.
Yeah, so again, it was kind of hitting the highlights. Kepware, HighByte saved us a ton of time, more reliable solutions, exposed a lot more data, much more flexible. Hub and spoke, 4 tenants that we use for making decisions, lightweight, report by exception, open technologies, and of course, I always forget a 4th one. I'll remember it as soon as I go on mute. Those kinds of decisions, plus the hub and spoke, or what we call the data broker and unified namespace kind of idea, creating that single version of the truth, huge value for the project that we'll work on. And this was a great example. Cool. Kyle, I don't want to take up too much time.
No, excellent. Thank you, Kevin and Tim. That is excellent. I mean, I'm sure I'm speaking for John as well, but it's just really awesome to hear directly from a user who actually used both of our technologies in a way that is really, really impactful. And correct me if I'm wrong, I believe you guys in HighByte put together a video surrounding this use case with a little bit more detail. Is that correct?
We created go ahead, John.
I was just going to say, I think Kevin and Tim did that without us.
Yep. Yeah, exactly. We created a YouTube video. It's up on our YouTube channel and made it available to everyone to see. And it gets into some of the same content and then digs in even further into a lot more detail. Oh, Omar, thank you very much in the comments. Edge-driven, report by exception, lightweight, and open architecture. I think I forgot the edge-driven part. I should not have forgotten the edge-driven because Kyle, you were already talking about that. My fault.
That's it. Kevin and Tim, I have a question for you guys. I'm often asked by prospects who are talking with us, how do we get started? And how long does it take? So when you were faced with this project, how did you kind of break it down and think about it? And then how long did it take for you to go from the project and once you had kind of a view of what you were going to do to actually implementing it?
Good question. So I'll speak to this when I'm keeping this company and this solution in mind, and also a lot of other conversations, and even one that I had just about an hour before we started this webinar here today. The company that was talking about we need to track WIP, where is inventory. That's great that they want to track inventory, or that's great that they want to replace old technology or to work on production efficiently. But what is the real business challenge you're trying to solve? Let's break it down. And so we start with that conversation. And so the first step is typically for us to get into what we like to call a digital 360, which is gap analysis with value stream map, focusing on data and ending in roadmap. That's the briefest explanation I can provide. Happy to give more details and all that kind of stuff, but it's getting into what are the challenges you have and then ranking them, putting them and figuring out what kinds of potential projects you can get, getting them into a roadmap and clearly defining that that business challenge. And then from there, you start to formulate what the pilot project is going to look like and how are you going to use it. What kind of problem, how are you going to solve that problem? And then that's what we ended up doing around this kind of solution. How can we replace the existing solution, solve their technical issues that they had, as well as some labor issues and other things, but also lay out the best kind of product or solution we can for the future. And so then we start to apply third step as we're defining, or maybe it's kind of in line with second step with a pilot, is looking again at those 4 steps. And everyone in the webinar, look in the comments. Omar was kind enough to provide them since I couldn't remember them all. Again, thank you. Shout out to Omar. Looking at those 4 tenets and making decisions on how you're going to implement that pilot solution. And then also including the hub and spoke, the Mqtt data broker, unified namespace ideas with that, and what you're going to, how you're going to execute that. And then at that point, the next step is to get a really strong alignment on executing that project successfully. And that then gets into a product owner, project manager, project charter, having the right focus, the vision, and all those other kinds of fun things, which I don't have time to talk about. And the process for getting up to the point of being ready to figure those things out, depending on whether it's decision by committee at the manufacturing company or not, preferably not, get the right people in the room, but let's make some clear, effective decisions. It's a matter of weeks, a month, to come to some good conclusions. It can happen quicker, or it could certainly take longer. Anything in the world could take longer, but it takes that long to get that design phase done. Then from there, putting a solution like this one in place, I think, what, 3 months, 4 months, Tim, something like that. Yeah, you nodded his head, yes.
Yep.
Yeah. So does that help answer your question, John?
Yeah, that's great. That's great. Thank you.
Yeah, and yeah, thank you. And I obviously, selfishly, I have a ton of questions for you guys. I think you guys are both a wealth of knowledge, and this, again, I'm just super fascinated by this. But thankfully, it's not all about me. We have almost 200 people here, and there are a lot of questions in the question and answer chat box there. So we're actually gonna go to those. Tori, do you want to maybe call some out, or do you just want me to read them off?
Hey, Kyle. Yeah, I mean, there's so many great questions in here. Definitely, I've seen several that talk around the historian component of the use case. Where does a historian come into play? It wasn't necessarily specifically called out in this use case, but where does that sort of fit into either this use case in general, or other clients that you're working with, or just Industry 4.0 mindset in general?
It is a big topic, and definitely needed in a lot of situations, but quite honestly, not every situation. Truthfully, in this situation, we were able to handle the data that we needed to store in SQL Server. And so SQL Server, I guess you could say, and Tim could confirm this, is effectively subscribing to the data source in the Mqtt data broker, or to HighByte. We also, like I see mention of a couple data brokers, or not data brokers, historians here, but we like Canary Labs a lot. So it's a really good product, and we're using it in a lot of other places. It has its place, but just to make sure you understand from an architectural perspective, what's most effective is to connect that historian to that hub and spoke. It's one of the spokes that then subscribes to that data broker, so that it can consume the data, maybe do a little bit of data modeling in there, and then push the data out to wherever it needs to go. Which one you want to cover next, Tori?
Oh, yep.
There we go. It's like the quote of 2020 and now 2021 here on mute. Okay, let's go to, I think this is a good question for John. Is HighByte using a workflow or script engine to do calculation orchestrations? How much scripting is involved in the solution?
So we do have an ability to do some light scripting in the modeling engine. We've got a expression field, I guess, on each attribute of your model. And that way you can bring in multiple input values from different systems, and you can run any calculation that you need. We're using a JavaScript scripting engine, and the real focus is to be able to standardize and normalize and contextualize your data. So it's not an analytics engine, it's an approach to allow you to standardize your data. But in doing that, a lot of times you do have to write some scripts. In fact, Tim, I know that you got into that a little bit and did some. Maybe you want to comment on what you did specifically in this case.
Yeah, I'll just use one quick example of where I use the scripting language. So like I talked about with the product coming across those conveyors, we wanted to model the destination bin. Which bin? Was it going to bin alpha, bin Charlie, or bin Bravo? And we did that with a little bit of script that took all the different Kepware inputs, oh, this belt is running, this gate is open, and just some simple logic, if then, this kind of stuff. And then the result would be the bin alpha, bin Bravo, bin Charlie. And so the model would say, when it went to Mqtt, this is the destination bin, it's going to bin alpha. So just simple switch and if then scripts, but that's just one example.
Thanks, Tim.
Great. Okay. I have another question here. This one's specific to Kepware. So maybe Kyle or Tim, you want to tackle this one. How about when Kepware data needs to be backed up without having issue and alarms when the data is used to get periodical alarm on the shop floor? Suppose customer wants data backup of historical data, for example, from the period 2016 to 18.
Sure.
Jump on that one.
Yeah, so that's interesting. And there's a little bit to unpack there. So when you're saying a backup of data, to me, I sort of interpret that as, hey, if there is a connection lost, like where does that data go? If that is what you're saying, then essentially what we're getting at is depending on what protocol you'll be using to get data out of Kepware is going to dictate on how that data gets backed up. And what I mean by that is if you're using let's say our IoT gateway feature, which takes that industrial data, transforms it into Mqtt, we do have a buffer within that service. So I believe it's like 100,000 events, and an event is defined as a single tag changing value. We can buffer up to that amount. But if you're using something like our data logger, which writes data directly to a SQL database, or if you're using the ThingWorx Always On protocol, which is, again, natively sending data from Kepware to ThingWorx, we do have a true store and forward, save to disk sort of backup for that. Now, if you're talking about from a historian standpoint, if you're saying, hey, can Kepware essentially get access to historical data that is already stored on a historian? The answer to that, unfortunately, is no. So Kepware really is a true real-time data acquisition engine. So while we can connect up to historian, in other words, sending data to historian, it's really, we cannot pull historical data directly from a historian. We can pull those real-time values, but why would you do that when you can just connect directly up to the device? So I guess I'll ask HighByte, do you guys have access to historical data through historians?
Yeah, so most of the historians today support a REST interface. Some of them are also supporting Mqtt, so we can pull data across via those protocols. And then we're also looking in the future to add additional technology for some of the leading historians so that we can optimize that. But yeah, there are a number of customers who are using us to pull data from historians into HighByte and then make it available to another system, as well as SQL, right? I mean, as Kevin said on this project, they didn't use a formal historian, they used a SQL database to store their data. So being able to pull and push into SQL is also important.
Great. Okay, another question here that got some great upvotes. Was there any comms in the reverse direction, i.e. writing to the machines in the specific Ectobox use case you shared? So maybe Tim or Kevin, you want to answer that one first, and then we can talk about that use case separately afterwards.
Yeah, so the short answer is no, there were no reverse writes, which was good for us because it meant we were able to replace the solution with no impact. But yeah, no data going back the other way to the PLCs.
There are other situations we're getting into where there is data going back to the PLCs. In fact, some of them are even around what you might call tech tables on particular machines that define and control quality. But for this one, there happens not to be any.
Yeah, we've got a number of customers who are looking into and are using HighByte or investigating to use HighByte to be able to run analytics in the cloud and then pull the results down as new set points for the PLCs. So we would consume it off, say, an Mqtt broker on maybe on a AWS Greengrass, and then publish it down into Kepware and we can publish multiple set points as one push down into Kepware by defining a model that has all those set points and then just pushing it down. So that's definitely possible.
Yeah, the tech tables I was even referring to are going to end up being set points, something we're looking at too. So same situation. Yeah, it's a good point.
Yeah, and I would echo what everyone's saying here as well. We are seeing talk of taking set points down and writing from the cloud directly down to the device. We have the ability to do that. We have yet to see it in practice. Not saying that it's not being done yet, just from a Kepware standpoint, no one here has actually seen that. It's possible, but again, not yet necessarily in production. And of course, like, you know, writing set points or pulling recipes from the cloud is great, but of course, and I feel like I just have to say this, like, you're not going to want to be controlling your servo motors from the cloud or anything like that. It really should be the higher level control set points, not necessarily flipping a switch from the cloud. That's a big no-no.
Yes.
Agreed. Safety and security #1.
Yes, exactly.
Here's another use case question specific to the use case that was presented. Is there a direct connection between the ERP and the Mqtt broker? Did the ERP actually talk to Mqtt? If so, which ERP was it?
No, it did not. I think on the diagram, there might have been a spoke showing that it went to Mqtt, but it did not. It went through HighByte, actually. So the ERP did not speak in Mqtt. Unfortunately, like most of the technologies they were using, it didn't speak any of the modern protocols and such. So HighByte handled all of that coming from the ERP back into the broker.
Yeah, that would be my fault for a bad diagram.
Well,
It was a great diagram.
Yeah.
Just one line.
Here's a good question on, it kind of gets to location, and I know we're coming up here close on the hour, and we may not be able to get to all of these. So if you don't hear your question answered live, I'm sure we'd be happy to follow up with you after this webinar. But let me sneak this one in. Like I said, question of location, it really gets down to edge or cloud. So if we need back and forth read-write data between platforms before you know, we can get it into a meaningful contextualized form, should that sort of contextualization be done at the edge or in a cloud platform? What makes sense? What do you do at the edge versus in the cloud?
I'd say again, you know, these 4 tenants, and Omar again was kind enough to call them out. Edge driven is one of them. Get as close as the edge as you can for making those decisions. We did not put, Tim will speak to this, we did not put HighByte right at the very bleeding edge, but it certainly wasn't in the cloud. Tim, kind of in a high level, where was HighByte located on their network?
Yeah, so it was located, like, you know, on the floor, but it was on a slightly higher network. But to answer the question, yeah, you model it as close to the edge as you can, but with Mqtt, then you can just push those models further up. You can push them to cloud Mqtt, or, you know, maybe even before the cloud, maybe there's another centralized. So you know, using the unified namespace, you model it as close to the edge as you can, and you can just push those models up through Mqtt all the way to the cloud if need be. So we model Kepware specific things as close as we can. Then some of the models need to include ERP data. You know, so we're modeling it as close as we can to the edge, so that the people who are on the floor making decisions based on that data, there's less chance of there being any interruptions or any failures. If you fail to read the data from ERP, okay, you'll have to deal with it, but at least you're getting all of your PLC data, you know, immediately and directly without any connectivity issues back to the central office.
One of the things that I've seen, Tori, to jump in on that one, is #1, you really want to look at who can do the modeling. I always go back to, it's a persona-based discussion, really, or it should be. Who can do the modeling of that data? And it's really, so in the industrial world, that's typically the OT team. And so if you're going to provide if you're trying to model data coming off of PLCs and coming out of the MES system, the OT team really understands what that data and the nuances of that data are. And so you want to produce a system for that team so that they can own the modeling of it. Because if someone else is owning the modeling of it, then those people don't understand it as well. They're constantly having to collaborate and better understand what's going on. And the other key point is not only who can model it, but who owns making changes. So the factory floor is not static. In fact, I was talking to a customer just today about, the R&D team is making changes to their product and pushing changes down to the factory, and so the factory is making changes. Well, if you're changing the PLC code or you're changing the machinery, you need the people that are making those changes to be able to adjust the models and adjust the data mappings. And so you need to put it in the hands of the people that are making those changes so that you're not chasing problems after the fact. And if you're, if one team has the responsibility of making the changes, but then another team owns the modeling of the data up in the cloud, then they're constantly going to be chasing after who made that change and what was the change and how do we remodel the data. So the focus, as I've always thought, is build a system for the team that really owns the source of the data so that they can structure it appropriately.
A couple of comments on that real quick that I think might be really helpful for everybody. This is actually something, the first of the 2 points I think you were kind of making there, John. The first one was something that Tim and I actually talked about early on when we were looking at HighByte, and that was one of the best types of solutions we can provide to any company is one that we can hand over and they can take ownership. We actually use that word, ownership of the solution. And the guy who built the system was retiring. They had other people working there. They weren't as familiar with software development and coding and whatnot as he was. But we knew that this product was something that they could use, and then they could start to take over ownership. And so, Tim, I think, would you concur that that was part of our discussion, was they would be able to start to take over ownership of this solution?
Absolutely. As I noted, you didn't need a software developer anymore to make these changes. Right. Those guys and gals that own that data can make those changes. They can manage it. So yeah, for sure.
And then HighByte does help with that centralization of changes too. In software development, we know very well, different people changing the system, chase your tail, et cetera. It ends up being bad overall. So HighByte really helped with that too.
Oh, you want to take us home? I guess my last question for all of you is like, what's next, and what if people want to learn more about these solutions?
Sure. Yeah. I mean, feel free. Well, again, there's a lot of great questions in the chat. So thank you for all those. If we didn't get to you, we do have access to all the questions. So we'll be doing our best to reach out as best we can to get your questions answered. And again, thank you for attending and thank you for those questions. At least from a panelist point of view, I mean, you're listening and you're interested, which is always nice to hear. But yeah, our information, as you can see, is up on the screen. Please feel free to reach out to any of us around the solution. I know that there were some questions in there around, hey, maybe I want to see a demo, or how does this work, with ThingWorx? Can I use HighByte without Kepware? Things like that. Absolutely feel free to reach out to us. John and I actually did another webinar, I think last summer, around Kepware and HighByte. Go check that out. I believe that's on both of our YouTube pages. The company YouTube, not our own YouTube page, but feel free to check that out. And yeah, thank you again. As a big thank you to Kevin and Tim. That was an excellent presentation, and glad the use case worked out super well. And thank you, John and Tori and the HighByte team for joining us.
Yeah, thanks for sponsoring this, Kyle. And I agree. Thank you to Kevin and Tim for joining us. This was great.
Yeah, thank you all.
Yeah, thank you guys for having us.
Check that firewall.
Yeah.
Thanks, guys.
All right.
We'll talk to you later.
All right, take care.
Thanks, everyone. Bye now.